Hello, class. Today we'll be looking at lesson 3.1.3, which is on the topic of systems of equations. The question that I want you to be able to answer by the end of the lesson is, how are solutions to a system of equations be represented graphically? So again, we're going to continue looking at graphs of equations, but you're going to be looking at a system of equations. A system is basically when you're solving more than one equations together. Okay, so first is going to be a review of solving systems with more simple equations. You're going to do this in your notebook. I want you to solve part A, B, C, D, systems of equations. As you can see, you've got more than one equations. You can do this on your own. You can do this with your group or your partner, but I want you to do this in your notebook, showing out your work. Find the solution, then explain or show what the solution tells you about the graph of the system. In other words, how is that solution going to look like on its graph? Pause the video, work on it, then please come back to the video to check your answers or work. If you get stuck, then yes, you can definitely come back to the video to watch and help you solve the system. Okay, I hope you're back now. First, let's check the answers. Now I'm going to go through each part of the problem, and I will also show what the graph will look like along with the solution on the graph. First, part A. Both equations are equal to y, so you can use what's called equal values method, where you're going to set both equations equal to each other. Negative 3x plus 5 equals to negative 3x minus 1. To solve it, I would add 3x both sides, but what happens is now you have 5 equal to negative 1, which is impossible. 5 is never the same as negative 1. Therefore, in this case, would be no solution. Now, graphically, what this means is that you have two linear graphs. The first one, this one, has a y-intercept of a 5 and slope of negative 3. So let's assume that it looks something like this. 3x plus 5, and the other one has a y-intercept of a negative 1 and also has the same slope of negative 3. So then same slope, meaning both lines are going to be parallel and they will never intersect. So I have explained that they are the same slope and thus they are parallel and they never intersect. Therefore, no point of intersection, no solution. Next one, same thing. They're both equal to y, so I'm going to set both equations equal to each other. Now, moving this minus 2x and adding 1 both sides, you're going to get 1/2 x squared minus 2x plus 2 equals 0. What you can do is to get rid of the fraction, multiply both sides by 2. X squared minus 4x plus 4 equals 0. You got a quadratic equation, which is factorable. Since both factors are the same, you're going to get x equals 2 as the only solution. However, I'm not done yet. My systems have two variables. It has both x and y. Therefore, I need to find the y value for this x as well. Plug in 2 into either of the two equations. Plug it in. I'm going to plug into the second equation because it's simpler. So I got x2, y3, which means my solution is going to be a point 2, 3. Now, on the graph, what it's going to look like is going to be a parabola, which is this for the first equation, parabola, and a line with positive slope. And what's going to happen is it's going to look like this. They're going to intersect at 1.2, 3. So therefore, there's only one solution because a parabola intersects at a line at one point, and there is a special term for this. So here, if a line is crossing a curve at only one point, we say that this is a tangent line. So again, tangent line is a line that crosses a curve at only one point. So that's called a tangent line. Tangent. You will see this word later on again, maybe in the lesson or in your homework as well. Part C. This time I'm going to use substitution, where I am going to change this equation in terms of x. So then this is going to be, I'm going to add 2 both sides. So x equals y plus 2. And then plug in that x into the x in the first equation. Okay. You could have plugged in the y squared into the x here. That would have worked too. So then I have this equation rewritten as x equals y plus 2. Plug it in there. You have y squared equals y plus 2. Make this equation equal to 0. Subtract everything to move it to one side. Here's your quadratic factor, y minus 2 times y plus 1. You get y equals 2 and negative 1. Same thing. In your original equation, you have both x and y. You already found the y. Now you need to find the x. I'm going to plug it into either of the 2 equations. You can plug it into the first equation. 2 squared is equal to 4. So x is equal to 4. And I have one solution. Negative 1 squared is equal to 1. So x equals to 1, which means my second equation is 1 comma negative 1. Here are my algebraic solutions. Graphically, this is a sideways parabola. So it's going to look something like this. And then the second one is going to be a linear with slope of 1. And what I'm going to show you is this. Sideways parabola and a line intersecting twice. 2 solutions. It's going to look something like this. And that's my graph. And this is what I want you to be able to do. We practice graphing a lot of different functions. So then I want you to recognize what the graph is going to look like. This is a sideways parabola. This is a line. I know that there are going to be 2 solutions. So how am I going to sketch the graph where they intersect at 2 points? Sideways, line with positive slope going through the parabola, 2 intersections. Last one. I'm going to use substitution again. Plug in the y in the second equation, this whole thing into the y in the first equation. You can do that. You get 4x minus 2. And instead of the y, I want to replace that with 2x minus 5 equals 10. 4x and a 4x cancel out. You end up with 10 equals to 10, which is always true. 10 is always the same as 10. In that case, we say that there are infinitely many solutions. And what is the graph going to look like? This, if I assume it to be a line, I'm going to do the bottom one, negative 5 y-intercept, slope of 2. Let's say it looks like this. I don't know. Positive slope. Then the second equation, the first equation will also be the same line. They intersect everywhere. Every single point on this graph together are a solution. Therefore, infinitely many solutions. Here's my explanation. Both equations are the same, so the lines are also the same, meaning they overlap. Infinitely many solutions. Now we're on to problem 45 on your handout. Now, before we get started on this, I want you to hear me out. Whenever you're doing a video lesson for this class or any other class, I want you to either first think about the problem on your own first, or do the problem on your own. Do it with your group, check with your group, and then come back to the video to either get some hints on how to start the problem. Okay, but if you got an idea, pause it again and do the rest. Or you finish the problem, you need to check it with me, come back to the video, watch it. So for problem 45, here's what you're going to do. You're given a system of equations. I want you to think about what kind of graphs they are. Okay, I've seen this equation. What is a graph going to look like? What is this graph going to look like? And I want you to make a predictions on how many solutions you could have with these types of equations. We're only going to pause the video for just part A right now. Pause it, do it on your own, come back. Okay, I hope you have your predictions. So let's first think about this. X squared plus y squared is equal to 25. That is a circle with center at 0, 0, because there's no h or k. H is 0, k is 0. But the radius is square root of 25, which is a 5. Next one is going to be a parabola, but parabola with locator point or the vertex at 0, negative 13. So let's see here. How many possible solutions can you have with a circle and parabola? If you weren't able to make any predictions, but if you have an idea now, feel free to do so. But how many possible solutions can you have with a circle and a parabola? Circle and parabola. This is 0 solution. You could also have a circle and a parabola intersecting only once. 1 solution. Can we have them intersecting twice? Yes. 2 solutions. How would you make them intersect 3 times? Again, anytime you can pause the video, do it on your own. But I'm going to do a circle with parabola inside of it. That's 3 intersections. 3 possible solutions. Can we have 4? Yes. Circle and parabola. Parabola a little bit outside of the circle like this. That's 4 solutions. Would it be possible to have 5? We can give it a try, but nope, I haven't found it yet. The only possible solutions are between 0 to 4 for a circle and parabola. Okay, then now moving on to part B. Again, I want you to pause the video first, do it on your own, but what you're going to do is you're going to solve by graphing and figure out exactly how many solutions there are. Graph the circle, graph the parabola, find all solutions. Okay, part B, here we go. Circle, center at 0, 0. Radius of a 5, so 1, 2, 3, 4, 5 up. 5 to the right. 5 to the left. 5 below. Got 4 main points there around it. And then I'm going to find extra points so that I can make a better sketch of the circle. Another good x value to plug in for your graph would be if you have x equals 4. Because if x equals 4, you get 4 squared, which is 16 plus y squared is 25, which means y squared is a 9. And that gives you 2y value, positive 3 and negative 3. So you can have 4, 3, or 4, negative 3. Of course, the same on the other side. If x is negative 4, you can have positive 3. The circles are symmetric. And then 1, 2, 3, negative 3. Yeah, you could do another one where x equals 3. Then you get 9 plus y squared is equal to 25. So y can be both plus or minus 4, which means you can have 3, 4, 3, negative 4. Same thing on the other side. Circles reflectional symmetry. So then I can do it on the other side here. And another one there. And that pretty much looks like enough points for me to make a nice circle. Now on to parabola. the parabola has a vertex of 0, negative 13. So start at negative 13, plug in other points. You're going to find another one at 1, negative 12. Make a table for you. 0, negative 13. You'll have 1, negative 12, which means you'll have another one on the other side. If you have a 2, you have 2, negative 9. To the other side, plug in a 3. You get 9 minus 13, which is negative 4. Ooh, right here. Right here. Then plug in a 4. Oops, sorry, 2, negative 9, and 3 was negative 4. Plug in a 4. Sorry, positive 3 actually. Positive 3. Ooh, another one. So then it looks like my parabola and a circle are intersecting at 4 points. If you weren't able to do this graph correctly, then I'm going to ask you to try it again. Do it again. You definitely want to be able to graph a circle and a parabola. So then now that we have 4 solutions, we need to find these solutions algebraically, and that's part C. You are now going to solve this system of equations algebraically using 2 methods. Both methods are described to you. I want you to solve using both methods. You must do both and decide which one is easier for you to use. First one, give you some idea. You're going to combine the equations together to create one new equation so that the only variable is x, no y, only x. For example, this y equals x squared minus 13. I'm going to plug it into the y in the first equation. So would you be able to do that correctly? What would it look like if you were to plug in? Just replace the y here with x squared minus 13. So you should have x squared plus, it's y squared, but I'm going to change the y, rewrite it with this. So now I have x squared minus 13 replacing my y, but I need to square it. The y had an exponent of 2, so I need to square this entire thing and then make that equal to 25 and solve from there. Give it a try and come back. All right, so if you got stuck, then you can go along with me, but here's what I'm going to do. I'm going to expand this, multiply it out. So first this is x squared plus x squared minus 13 times x squared minus 13 equals 25. So you're going to have to multiply out this whole thing. So first, that's x squared times x squared, which is x to the 4th, minus 13x squared, minus 13x squared, negative 13 is 169. And then I should still have an x squared at the front. Combine them all together. That's x to the 4th minus 26x squared plus 169. And then you got an x squared. Then x squared minus 26x squared, I can combine them together. That's going to be x to the 4th minus 25x squared plus 169. Subtract 25 both sides. I got x to the 4th minus 25x squared plus 144 equals 0. And that's the equation you're going to have to solve. If you're stuck there, that's normal. How are we going to solve this? Here's what I'm going to do. The u substitution. So do you see how there's an x squared being repeated? Okay, if we let u be x squared, that's the repeated piece. This is basically u squared minus 25u. So it's going to look something like this. It's going to look like a quadratic. So then if you can factor this, it's going to be u minus 16 and u minus 9. It's a quadratic you can actually factor. Negative 16 plus negative 9 is negative 25. Negative 16 times negative 9 is 144. So this is actually a factorable quadratic, but this is in terms of u. right? I let u be the x squared. Instead of writing it in a complicated equation, I just rewrote it in a simple quadratic. Since this is factorable, and this is in terms of u, now let's do it with x. This is x squared, and this is x squared squared. So I'm going to factor it the same way, where I have -16 and -9. But this time, since I have an x squared and an x to the fourth, I know that x squared times x squared is x to the fourth. -9x squared and -16x squared combine to be -25x squared. So same pattern, but instead of writing as a u, I'm writing as an x squared, because that's what I have in my original equation. Then from then on, I have difference of squares. I can factor even more. This is a difference of squares, so x plus 4 times x minus 5. This one over here is x plus 3 and x minus 3. And I got so many solutions. I got x -4, x equals 4, -3, +3. So far it makes sense because I got 4 points of intersection, so I should have 4 solutions. Now I need to find the y value. So plug in each x values into any of the equations. I'm going to plug it into the second one though. To me, that's easier. So -4 squared minus 16. 16 minus 13, which is 3. So -4 comma 3 is 1. Next one, same thing. 4 squared minus 13 is +3. So 4 comma 3. Plug in -3. Y equals -3 squared minus 13. That's -4. Plug in x equals 3 into the second equation. 9 minus 14, which is also -4. We got 4 points of intersections, which are exactly the same as what we found on the graph. That was a lot of work. So then method number 2, let's see if that's any easier. This time you're going to have x squared plus y squared is equal to 25, the original system, but solve this by using only the y. Rewrite this equation as one equation, so you only have a y. Think about what you did here. I plugged in the y in the second equation into the y of the first equation. So find another way to change this into one equation, but only with the y remaining. So what if we plug it into the x squared? Can we plug in that second equation into the x squared in the first equation? Yes. I'm going to rewrite it. Add 13 both sides, so you get x squared equals to y plus 13. And then you can plug that into the x squared in the first equation. So then what you're going to have, you still have the y squared equals 25, but then instead of writing it as x squared, you're going to replace the x squared of the first one into y plus 13. They're exactly the same. So just rewrite that whole thing as y plus 13. This is what you should have, or you could have. So then I'm going to rewrite this as y squared plus y plus 13. Make this equal to 0. This is your equation. It is factorable, and you get 2 solutions. Y -4, y +3. You need to have both x and the y in your solutions because your original problem has both x and y. So now you need to find the x. Plug it into an equation. I think this time I'm going to plug it into the first equation. Because then if I put in -4, I have to solve it. Doesn't matter which one you choose, but I'm going to do the first one. So I got x squared plus -4 squared equals 25, which is 16. X squared is equal to 9. So if you square root, don't forget x equals both plus or minus 3. And that means when x is 3, y is -4. When x is -3, y is also -4. So that's 2 solutions there. The other side, same thing. Plug in y equals 3 into the equation. X squared plus 3 squared, which is equal to 9. Subtract 9 both sides. X squared is equal to 16. Square root positive or negative 4. So when x equals positive 4, y is 3. When x is negative 4, y is also 3. And here are my 4 solutions, which is exactly the same as the solutions I got on the graph. So ask yourself, which one do you think is easier? Would you rather solve an equation with x to the 4th and do all this? Or would you rather solve an equation with y squared? I definitely think this is easier. And the purpose of this is for you to compare it, see which one's easier, and then next time when you do it, I want you to recognize and always make sure you plan ahead so that if you try this and you got an x to the 4th, you immediately know that's going to be too complicated. So then try another method. Then find the one that's easier for you and solve. All right, so we're on to the last problem, and this one's going to be definitely a little bit shorter, but this is a problem that's going to require you to think more. Me telling you or teaching it to you is not going to help you. So you're given the same system, the circle and the parabola that we graphed earlier. What small changes can you make to either one of the equations or both so that they have no solution, 3, 2, or 1 solution? For example, no solution was when they did not intersect. So how would you change an equation so that your circle and the parabola have no solution? How would you change the equation so it looks like this? Or how would you change the solution? How would you change the equation so it looks like this? No solution. Come up with all your ideas and come back to check. Okay, so let me share with you the option for no solution. First, here's a graph. How would you make it so that they do not intersect? Well, first thing is you can move this parabola up so that the parabola is above the circle, isn't it? This is 0,5, so you can have your circle above it. So here's what I have. Shift the parabola up so that this vertex is above 0,5. It's above the point on the circle. So here's an example. I changed the parabola equation to plus 8. So then the vertex is at 0,8. It's still above the circle. There's a lot of different options, but that's one example. Another option would be to reflect the parabola so that now it opens downwards, right? You could have a parabola opening downwards this way. Then they will not intersect. So how would you do that for the equation? How would you change the equation to make it reflect across the x-axis? All you got to do is you keep the circle, but then the parabola, you're going to multiply that whole thing by a negative. So you're going to have a negative for the x squared, right? Because if you have y equals x squared, it's a parabola opening up. But if you have y equals negative x squared, it's a parabola opening down. So then the equation for the parabola is going to be y equals negative x squared. And then I'm still going to keep the vertex the same at negative 13. So now you can think about for one solution, what would that look like? And you can pause the video and come back. So one solution, I can have the circle and not here, but the parabola will be like right on the top. Or you can have a circle and parabola at the bottom opening downwards this way. Okay. How would you change the equation to make this happen? Okay. Well, for the first one, if I were to move this parabola so that the vertex is right on the circle, that means I need to move this up. And I'm going to move it up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If I move this parabola 18 units up, this vertex will be right here. So for that one, what is my equation going to look like? Circle stays the same. But then my parabola, which was y equals x squared minus 13, but since I'm going to be adding 18, moving it up 18 units, it actually becomes x squared plus 5. That's what it becomes. So the vertex is at 0, 5. For the other one, if I were to have it upside down on one point of the circle, that means the parabola, the vertex has to move up to here. 1, 2, 3, 4, 5, 6, 7, 8. Move up 8 units, but then reflect it. So that vertex over here, so it looks like this, but then I want one solution, so reflect it across. So then same thing, circle is going to stay the same. I'm just moving the parabola. The parabola was originally y equals x squared minus 13, but I'm going to reflect it upside down, so it's going to turn into a negative x squared. And then up by 8 units, I'm going to have to add 8 to it, which means negative 13 plus 8 gives me negative 5. And that's my new parabola. So then, 2 solutions. How would you do it? Move it up again so that the parabola will be maybe over here. That's 2 solutions. Or reflect it. Flip it over and have the parabola like this inside the circle. How would you change the equation? That's 2 solutions. 3 solutions. I can move it up just enough so that the vertex is right on the circle, and that will give you 3 solutions. Same thing, reflect it, and then move it up so that the vertex of the parabola is here. So then this is also another 3 solutions. Here are the possibilities for 2 solutions. Vertex of the parabola inside the circle, right? Opening up and down. While inside the circle is the vertex. 3 solutions, opening up or down, but the vertex is on the circle, on the edge of the circle. Okay. If you do have any other ones, feel free to share that with me. Maybe take a picture and send it to me in the email or Canvas message, and I can check that over for you. But this is the end of today's lesson. Please feel free to check the other video for any homework questions.